Welcome to Definite Integrals, Part 1, last lesson in Part 1, the average value of a function. Let's get right at it. Okay, the area of this rectangle is the base times the height. So what is the height with respect to the area and the base? Divide both sides by the base, and the height equals the area divided by the base. So, on a function that's not really nice, the average height is the area divided by the base. Okay? What is the length of this base down here? Well, it's 1 over c minus a. Sorry, no, the base is c minus a, the two x values. The area is the integral from a to c f of x dx. So, this right here, I'm not sure you can see that, so let me move it up for you. There you go. That formula right there, that is the average value of a function. Okay, the nice thing is because it involves integration, it may be that we try to find the average value of a function and estimating using a Riemann sum or a trapezoidal. It just depends. So this could apply to anything that we've done with integration so far. So let's go ahead and move on. Okay. Find the average value of sine x on 0 to pi. Okay. So, the average value would be 1 over pi minus 0, the integral from 0 to pi, sine x dx. So, 1 over pi times, okay, what's the antiderivative of sine x? Good, negative cosine x. Evaluated at pi and 0. Alright, so 1 over pi. Okay. Cosine of pi is negative 1, so the opposite of negative 1. Subtract. The cosine of 0 is 1, so we're subtracting a negative 1. So our answer is 2 over pi, which ends up being approximately 0.63662. So there's our answer right there. Alright, let's move on to the next example. The depth of water in a tidal basin can be represented by the formula h of t below, where t is the time in hours starting at midnight and h of t is measured in feet. What is the average depth of water between noon and 3 p.m.? So, here we go. 3 minus noon, actually 3 minus 0, kinda, or 12, but that's not going to work, so 1/3 the integral from, let's see here, noon is 12 hours after, and midnight, and 3 p.m. is 15 hours after midnight. negative cosine pi t over 12 plus 4 dt. And I think I'm ready. I think we're ready to anti-differentiate. Alright, so we have 1/3 times, we've got negative cosine, oh no, you dummy. The antiderivative of negative cosine is negative sine of pi t over 12, and I need to multiply that by 12 over pi plus 4t evaluated at 15 and 12. So 1/3 negative sine. Okay, 15 pi over 12 would be 5 pi over 4 plus 60. Oh, no, I forgot about the 12 over pi. Okay, so negative 5 pi over 4, that multiplied by 12 over pi plus 60 minus, okay, let's see here, negative sine of 12 pi over 12 multiply that by 12 over pi plus 48. So 1/3 times, let's see here, 5 pi over 4 is negative root 2 over 2, but we have a negative sign in front of it, so root 2 over 2 times 12 over pi plus 60 minus 48 so 1/3 of, let's see here, 2 and the 12 will cancel, 6 root 2 over pi plus 12. So 6 and the 3 will cancel, 2 root 2 over pi plus 4. That'll end up being 4.90032. And you know what? At this point, you probably are not going to have to show all of this work here. I just like doing it. So if you want to use your calculator to evaluate that to get 4.90032, that's fine with me. Okay? And let's move on to the last example. It looks a lot like a free response, so why don't we get right at that. Whoa, Nelly. I'll let you go ahead and read that, and then I'll start back up for you, okay? And you probably can't see the first part of A. So what I'm going to do is I am going to move it down just a little bit so you can see what A is. Alright. Use the data from the table to approximate the average decay rate in grams per minute of a radioactive substance over a time interval of 0 to 24 minutes using a midpoint Riemann sum approximation with 3 subintervals of equal length. Those 3 subintervals will cover 0 to 8, 8 to 16, and 16 to 24. The nice thing about these equal subintervals is you have midpoints already found, which is really nice. So this will not take too much. Okay, so that approximation is going to equal 24 minus 0, 1 over 24. Okay, and we're going to have 3 rectangles. Each of them are going to be 8 wide. And the height, well, we're going to find that out using midpoint. So the height at 4 is 221 plus 8 times 12, the midpoint, 82, plus the height at 20 is 22. Down a little bit more. Let's see here. Add those all up and you get 2600. So 1/24 of 2600. The average value is 108 and 1/3 grams per minute. Okay, approximate r prime of 12. Show computations that lead to your answer. Go back up. Look at 12. Okay, we're going to do r of 16 minus r of 8 all over 16 minus 8. That will give us an approximation for r prime of 12. So r prime of 12 is going to be r of 16 minus r of 8 all over 16 minus 8. Alright, r of 16 is 39. R of 8 is 130 all over 8. That will be negative 91 over 8. That will be negative 11.375 grams per minute squared. That's the acceleration. Okay. C. A physicist proposes a function g given by g of t equals that. I'll let you just copy this down, and I'm going to move on after that because I've only got 2 minutes left. So go ahead and copy that down, and then we'll get right at it. I don't need to read it to you either. Alright, so the average value in those 24 minutes, 1 over 24 times the integral from 0 to 24 of 320 times 0.88t2 raised to the t power dt. And guess what I'm thinking? I'm thinking that the only way you're going to be able to do this is with using a calculator. So you're going to put this in a calculator and figure out what that is, and then multiply that by 1/24. And when you do, 100.97239 grams per minute. Hey, and then that brings us to D. Okay, find, alright, g of t equals 320.882 to the t power. Take the derivative of that and then find that value at 12. I'll let you go ahead and do that. Okay, the derivative of that is take the ln of the base multiplied by the exponential. And when you do that, you get an answer of negative 8.90503 grams per minute squared. This does conclude definite integrals part 1 average value.